In this question number 2, ethanol can be oxidized by acidified potassium dichromate 6. We talked about this earlier, the H+, the K2Cr2O7. This is chromium plus 6, dichromate Vi, that stands for chromium plus 6 there. Very important oxidation number. You go to chromium 3+, which is chromium plus 3, orange to green coloration. Now you want to oxidize this all the way to ethanoic acid, because if you think about ethanol, you have a carbon with the OH, and the carbon with the OH is bonded to 2 other hydrogens. So you could lose it sequentially, CH3C, and then you will get the aldehyde, where you still have 1 hydrogen on this original carbon with the OH, but now there is called an aldehyde, which is called ethanol. There is an aldehyde. This is your primary alcohol, which is your ethanol. And then that can get further oxidized to give you your carboxylic acid, so no more hydrogen on this carbon with the OH originally. So this is your complete oxidation. To stop at aldehyde, we need to heat and distill immediately. But this question is asking you about oxidation to ethanoic acid, so we need to reflux it together with your acidified dichromate 6. Describe what happened when it's reflux, why it is necessary. Describe what happened when it's reflux, okay? This is 3 marks. Why is it necessary for complete oxidation? Okay, so in reflux, I should probably save some space there. In reflux, the oxidizing agent mixture, and the ethanol are heated to high temperature, and then what you will do is you will then should probably delete this because I'm running out of space there. Maybe I'll just put it at the very bottom, and then we can play around with the space later on. So in reflux, the oxidizing agent mixture and the ethanol are heated until they boil, because you gotta heat until they boil. If not, they are not refluxing. They react at high temperature. To first form the aldehyde, but nothing escapes because you have a vertical condenser. So your condenser is not set up sideways. Vertical condenser or condenser placed vertically will condense the ethanol back to the reaction mixture, and therefore it can get further oxidized to be further oxidized all the way. So further oxidation means you keep on losing the hydrogen even on the aldehyde, which cannot escape because it's reflux apparatus to your ethanoic acid. So why is it necessary? Well, because ethanol has a lower boiling point. Lower boiling point, or ethanol boil first before alcohol, before ethanol. And the reason for that is because if you think about it, the alcohol can form hydrogen bond, but not your ethanol, because your hydrogen is not bonded to the oxygen in ethanol, okay, in the aldehyde. So we cannot allow ethanol to escape. Therefore, we condense it back down with the vertical condenser. Otherwise, if we allow it to escape, then no conversion. Because if you don't have the ethanol, how can you go to the ethanoic acid? Then no conversion or no oxidation to the target ethanoic acid, which is what we are doing here. So we want to ensure the conversion. In order to do that, we have a vertically set up condenser, which you should be able to draw the apparatus setup. This is like the pear-shaped apparatus for setting up a reflux, and we have a vertically set up condenser. You should really know that water goes in at the bottom. So this is H2O in at the bottom. So H2O in, and then H2O out. And you leave the top open so that the gas doesn't build up pressure. So this is your condenser set up vertically. This is your reaction mixture. But of course, we really need to heat up. So, so that is your heat there. I'm sorry that my diagram is not as nice as it should be, but you get the idea there. We do need to heat. Okay. Anyway, so that's basically the complete oxidation to the ethanoic acid. And what else do they want? They want you to write a half equation. Write a half equation for the oxidation of ethanol into ethanoic acid. So this is oxidation. Oxidation is loss of electrons. In this kind of question, it's probably easier if you use molecular formula. So in ethanol, we know it's C2H5OH. In ethanoic acid, we know it's CH3CO2H. I'm just going to use C2H6O. It's easier to balance the equation this way because we're just looking at the atoms. So that's C2H4O2. I know I must lose electrons. So the thing on the left must lose electrons to go to the right. So the hydrogen is not balanced. The oxygen is not balanced. I know I need more oxygen on the left. So what I'll do is I will add H2O. Give me one extra oxygen. Give me extra hydrogen. So I do this in the presence of acidified dichromate 6. Acidified, there is acid in the system, giving me H+. Now the 6 plus 2 is 8 hydrogen. This is 4, so I need 4 H+. No charge on the left, 0 charge on the left. Minus 1 for each electron. Plus 1 times 4 is plus 4. So I need 4 electrons to balance my equation there. Balance atom and then balance charges for your half equation there. What else do we know here? Describe how you obtain a sample of ethanol from a mixture of these 3 compounds. Describe how you can obtain it. So you got to talk about description of your apparatus. In fact, you also need to talk about minimize the loss of ethanol. You can be describing in words or a label sketch. I'll probably do a label sketch where I will have a sideway condenser. This is about distillation. So I will have a sideway condenser. And I must have a thermometer there, and a seal vessel. So my thermometer is not well drawn, but you just need to label it. And my condenser, my water is in at the bottom. And what else do I have? I have a condenser, water out from the top, as you would know from IGCSE anyway. And I would have my ethanol here. But I want to minimize the loss of ethanol. So what I can do is I can set up an ice bath. So this could be an ice bath so that to prevent or to minimize the loss of ethanol, to minimize it boiling off, because its boiling point is very, very low. If you look at the boiling point, it's 21 degrees Celsius. So you don't want it to boil off at room temperature. So what we have on the other side, this is going to be your ethanol plus your acidified dichromate 6 oxidizing agent. And of course, you do need to heat it up, okay, with a heating vessel there. And what is this technique called? This is called simple distillation. And simple distillation works because, you use it as a separation technique based on the different boiling point. So which one will boil first? The lowest boiling point ethanol will boil first. So lower boiling point ethanol will boil first, and therefore it get condenses first. So therefore condense first, and then collected in an ice bath. The ice bath there prevents it from vaporizing due to the low boiling point, as you could see, 21 degrees Celsius there. And I guess for the 5 marks, they didn't ask us why we don't get ethanoic acid. This is a distillation apparatus where the product escapes sideways. But in the previous question, we have reflux where the ethanol does not escape sideways. It gets condensed back down and emits the oxidizing agent. And therefore, you can further oxidize the ethanol all the way to ethanoic acid. That's why reflux is essential to get the carboxylic acid oxidation from primary alcohol. But heat and distill immediately. heat and distill immediately is a very important condition if you want to specifically stop at aldehyde without it going all the way to be oxidized to carboxylic acid there. Part D, the last part of this question, use your knowledge of structure and bonding. Why is it possible to separate ethanol in this way? So we can talk about ethanol here versus ethanol. So this is ethanol. This is ethanol. Structure and bonding. So this was what I mentioned just now. So ethanol cannot form hydrogen bond. Ethanol only forms permanent dipoles between itself. Permanent dipoles between itself. As well as London dispersion force, of course, and London dispersion forces, or weak van der Waals. Whereas we talk about the ethanol. Ethanol can form hydrogen bonds, and hydrogen bond is basically much stronger. Can form hydrogen bond in addition to the London dispersion forces, London forces. So what we can really say is we talk about the strength of the intermolecular forces. So you gotta justify it by talking about hydrogen bond require much more energy to break because hydrogen bond is stronger than London dispersion force, then permanent dipole because there is the strongest intermolecular forces between ethanol. Stronger than permanent dipoles, therefore require much more energy to break, and therefore alcohol has higher boiling point. So aldehyde has lower boiling point, and if aldehyde has lower boiling point, it will boil before alcohol, and therefore you would collect the aldehyde before you can collect the alcohol there. Okay, so hopefully that makes sense then. So this last part of the question, we have a student obtaining a sample of the liquid using the apparatus in part C. So part C was simple distillation. Part C was simple distillation to get the aldehyde specifically. So that means there was the heat and distill, and they will have gotten the aldehyde. So this is to obtain the ethanol, which is the aldehyde. Aldehyde is named with the Al at the end. Describe the student could use chemical test to confirm that it contained aldehyde and did not. Did not mean it's going to be negative for ethanoic acid. So this is described for 5 marks. So we're going to think about a couple of tests. So number 1 is it contained ethanol. Number 2 is did not contain ethanoic acid. So negative for ethanoic acid, positive for ethanol. So if I do the test, if I add a tolerance reagent, so to a sample, to a portion, maybe I can say divide sample, divide the sample into separate test tubes. Let me guess, we'll probably leave a bit of space. Later on we can think about all the tests that we can do. Okay, so to the first portion, to the first test tube, or to the first portion, I guess, what do we add? We can add some tolerance reagent. So tolerance reagent is basically your silver with NH3 twice. This is a colorless solution that you obtain by dissolving silver chloride precipitate in excess aqueous ammonia to give you this tolerance reagent. And then we will see, what do we see? Silver mirror forms because aldehyde is present. So this indicates that aldehyde is present. So our product contains aldehyde. What else can we do to confirm that it is aldehyde? We can do another test. So to the second portion, what I can do is I can add Fehling's reagent. So Fehling's reagent contains copper 2+ in solution, among other things. Okay, I'm not saying it doesn't contain other things. It contains copper 2+ in solution, so it is a blue solution. And now you will get a red precipitate because it goes from the copper 2+, copper +2, and it will form this brick red precipitate, which is basically copper 1 oxide, just like your Benedict solution test in biology. and this actually proved that aldehyde is present. So previously you had the silver plus 1, becoming silver 0, that is your silver mirror. Silver mirror is silver element. Silver element is 0 oxidation number as an element. So you have copper plus 2 in the solution, that is blue in solution. You get copper plus 1, this is copper 1 oxide, which is the brick red precipitate. Last but not least, what I can do is to the third portion, I can do a test for ethanoic acid. So what I do is I add some sodium carbonate and Na2CO3 solid. All acid will react with carbonate, including weak acid, but I will get no observable change. I don't get any bubbles, no effervescence, so no effervescence, no change at all. And what does this tell me? Therefore, this tells me that no carboxylic acid group is present, no acidic group is present. Therefore, this will confirm that this is not an ethanoic acid. It does not contain any acidic group at all. And I guess that's as much of a description I can do for 5 marks. But at the very least, don't just write down one test for the aldehyde. I would probably write down 2 different tests so that I can see that the space is filled up, and it makes more sense, like there are around 2 points and 2 points and 2 points there. Also to confirm that carboxylic acid is absent, but aldehyde is also present. Descriptive, so make sure you give details, all right? And that's the end of that 5 marks part, and that's the end of that 60 marks overall question. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. And do get in touch at my number, country code 673, and then the number is 8656158 to arrange private tutoring where I can go through any syllabus, any examination body questions, any question of your choice, to be honest, or just going through concepts. Do get in touch for private tutoring. So hear from you soon, and thank you for watching again. I'll see you in the next tutorial video.